Assalamu alaikum wa rahmatullahi wa barakatuh. This is the Synergy project video for Introduction to Civil Engineering. We are Group 10 from K1S2. We consist of 5 members. We have Noor Azmina, Muhammad Noor Irfan, Riana Sayakini, and Muhammad Hakim, and lastly me, Ismail Ali. The content of this video are going to be the 4 main subfields in civil engineering and the 4 assignments from 2 different groups. Civil engineering consists of 4 main subfields. We have structural engineering, environmental engineering, hydraulics and hydrology engineering, geotechnical and transportation engineering. Our group assignments were on structural engineering and geotechnical and transportation engineering. And our partner group's assignments were on environmental engineering and hydraulics and hydrology engineering. And we received information about environmental engineering and hydraulics and hydrology engineering from our partner group since that was their assignment. And we met with our group here, as you can see, with the use of Google Meets. And this is the meeting between our 2 groups. And as you can see, everyone is present here. We discussed our assignments, and we received information, and also we gave information.
What is structural engineering? Structural engineering is specialized in the planning and evaluation of infrastructure including buildings, bridges, tunnels, and other structures. There are 4 structural engineerings. First is structural analysis, second is structural design, third is material engineering, and fourth is construction monitoring. Structural analysis. It examines how structures behave under various loads and circumstances. Calculating forces, stresses, and deformation is necessary to make sure the structure can handle its intense use safely. There are 2 types of structural analysis. First is static analysis. It examines the equilibrium of forces on a structure when it is at rest. This includes calculating reaction, internal forces, and deformation. Second is dynamic analysis. It considers the dynamic response of a structure to external forces, including seismic, which is a vibration or wind loads. This is important for structure where dynamic behavior is significant. Structural design. Based on the analysis, structural engineers design the components and systems that comprise a structure. This includes selecting the proper material, proportion, and connection to ensure structural integrity. For example, to determine the structural system that best suit the project requirements. This involves selecting the types of elements, beams, columns, slabs, and their arrangement to form a cohesive and efficient structural system. Material engineering. Structural engineers work with a variety of materials such as concrete, steels, wood, and composite. They must understand the properties of this material and how they behave under different conditions. There are several factors to be considered when choosing a suitable material. First is strength, second is thermal conductivity, third is electrical properties, fourth is corrosion resistance, and lastly, cost. Construction monitoring. Structural engineers frequently supervise the construction process to ensure that the project is erected according to the approved design and meet safety standards. There are some key aspects of construction monitoring. First is quality control. Construction monitoring entails continuously assessing the quality of material, workmanship, and construction procedures. It also ensures that the construction fulfills the required standard and follow best practices. Safety monitoring. Safety is a top priority in construction project. It is to ensure that safety rules are followed and the possible risks are identified and addressed in order to provide a safe working environment for all employees. Lastly is cost control. It is to ensure that the project stays within the budget and assess the status of work in according to the budget and manage unexpected cost overruns.
Engineering transportation refers to the application of engineering principles and practice to the planning, design, construction, operation, and maintenance of transportation systems. This field involves the development of efficient, safe, and sustainable means of moving people and goods from one place to another. Engineers specializing in transportation work on various modes of transportation, such as roads, highways, bridges, railways, airports, and public transit systems. Traffic engineering is a specialized field within transportation engineering that focuses on the planning, design, and operation of traffic systems to ensure the safe and efficient movement of vehicles, pedestrians, and cyclists. Traffic engineers study the movement of vehicles on roads and intersections, analyzing factors such as traffic density, speed, and flow patterns. Traffic engineers assess the capacity of roads and intersections to handle the traffic demand, and they use the concept of level of service to measure and describe the quality of traffic flow. Designing and optimizing traffic signal systems to regulate the movement of vehicles through intersection and improving safety. The next is infrastructure design and environmental consideration. Infrastructure design of civil engineering involves planning and creating the physical and organizational structure that support human activities and society function. This can encompass a wide range of facilities and systems, and is crucial for ensuring the functionality, safety, and sustainability of communities. For transportation infrastructure, such as roads, highways, bridges, tunnels, railways, airports, and public transit systems. For structural infrastructure, they including the buildings, dams, and other structures that provide shelter, storage, or protection. The next is geotechnical engineering. Geotechnical engineering is a branch of civil engineering that deals with the behavior of Earth's material, primarily soil and rock, and their interaction with structures, foundation, and the environment. Geotechnical engineers use principles of soil mechanics and rock mechanics to design and analyze foundation for structures, slopes, and embankments. Site investigation is a crucial phase in geotechnical engineering and construction projects. It involves gathering information about the subsurface condition at a specific location to assess the geological, geotechnical, and environmental factors that may impact the design and construction of structures. Foundation design in geotechnical engineering involves determining the type, size, and type of foundations that will support structures safely and efficiently on the underlying soil or rock. The goal is to ensure that the foundation can distribute loads from the structure to the ground without causing settlement, tilting, or other undesirable effects. And the last one is about geosynthetics. Geosynthetics are synthetic materials used in geotechnical engineering to enhance the performance of soil and rock in various civil engineering applications. These materials offer a range of properties such as strength, durability, and filtration capabilities, and they are employed to improve the stability, drainage, and overall behavior of geotechnical structure. For example, geogrids. We use high-strength material for soil reinforcement. Geogrids are often used to improve the stability of retaining wall, slopes, and embankment.
Hydrology engineering is the applied study of water-related physical and chemical processes. The goal of hydrology is to understand how water interacts with various factors to produce various natural phenomena which relates with the study of surface water, groundwater flow, erosions, water quality, water resources, coastal engineering, water treatment, and water supply systems. Engineers utilize this data to formulate solutions for the management of different water resources. The dams are engineered structures that are built across waterways to create reservoirs for the storage and release of water. The dams can be used for hydropower and water resources. The major functions of dams include water storage, flood control, water delivery, irrigation, hydropower generation, and recreation. In dams engineering, a major concern is the stability and maintenance of the dam itself. The design must be able to withstand the immense pressure of water, erosion, and sedimentation, and must also have ways to release the excess water when necessary. That's why the stability and maintenance of the dam is crucial and must be able to withstand environmental factors. Coastal engineering is an integral field of hydrology engineering which focuses on the design, building, and construction of coastal structures. It mainly deals with two aspects. One is shoreline erosion and stabilization, which is a major problem in coastal areas where erosion is severe that causes shoreline degradation. And the other aspect is coastal navigation, which is all about the sea level impact and tidal effects that creates issues for the coastal navigation. The engineers are responsible for the design and construction of piers, harbors, seawalls, breakwaters, and jetties. Therefore, coastal engineering plays a crucial role in coastal protection and maintenance of harbors and piers. Irrigation engineering deals with the development of efficient irrigation systems to increase crop yield with limited water resources. Irrigation system is used to convey water from natural sources to agricultural lands for farming. It is an efficient system used to ensure the availability of water to crops during dry periods. It is related to the management and control of water flows. An irrigation engineer have to make a detailed design taking into account the water sources, water distribution network, irrigation scheduling, and maintenance. This is to ensure that the system is functioning properly and there is no problem like leaks or blockage, thus increase in productivity and crop yield can be acquired. So to conclude, hydrology engineering is the applied knowledge of water-related physical and chemical processes. It covers various fields like surface water, groundwater flow, erosion and sedimentation, coastal engineering, water treatment, and water supply. It plays an important role in managing water resources and ensuring sustainable development. These fields are often interconnected and work in harmony to manage water effectively. The importance of hydrology engineering should be understood by everyone to manage and protect our natural water resources. That's all. Thank you.
Next is environmental engineering. An introduction. Environmental engineering is a branch of engineering that focuses on addressing environmental issues and challenges through the application of scientific and engineering principles. Environmental engineers work to develop solutions that protect and improve the quality of the environment, including air, water, and soil. Their goal is to create sustainable systems and infrastructure that minimize the impact of human activities on the natural world. Subfields in environmental engineering. The first one is water resource engineering. This involves managing and treating water resources such as surface water and groundwater, as well as designing a system for drinking water supply and wastewater treatment. Next one is air quality engineering. This deals with controlling and reducing pollutants in the air, including the design of systems for monitoring and removing pollutants from industrial emissions. The last one is solid waste management. This involves the collection, transportation, and disposal of solid waste, as well as the design of systems for recycling and composting. As you can see, this is the assignment during Environmental Engineering Week, and we need to do the graph data of average water consumption in 2023. Then we also need to do the graph data of average energy consumption in 2023. There are three strategies to reduce water consumption. The first one is water-efficient fixtures and appliances. Water-efficient fixtures and appliances are key strategies for reducing water consumption. By installing low-flow toilets, food shades, and shower heads, significant amounts of water can be saved without sacrificing functionality. The second one is water recycling and reuse systems. Water recycling and reuse systems are important strategies for reducing water consumption. These systems involve collecting and treating wastewater for reuse in various applications. By implementing such systems, it can significantly decrease their reliance on fresh water sources. Third one is leak detection and repair procedures. Leak detection and repair procedures is also a good strategy to reduce energy and water consumption. Leaks in pumping systems can result in significant water wastage over time, leading to higher utility bills and unnecessary strain on water resources. Three strategies to reduce energy consumption. First one is renewable energy sources. Renewable energy sources such as solar, wind, and hydropower offer a clean and good alternative to conventional fossil fuels. Solar energy has the potential of a renewable energy by converting sunlight into electricity. Solar power not only reduces dependence on non-renewable resources but also causes harmful emissions associated with traditional energy production. The second one is energy efficient appliances. Replacing incandescent bulbs with LED bulbs is not only more energy efficient but also has a longer lifespan. Energy efficient appliances are designed to operate with minimal energy waste, leveraging advanced technologies to perform tasks while consuming less power. By choosing these appliances, individuals will lower their energy efficiency. The third one is building design. Sustainable building design starts with an understanding of the environmental impact of construction materials. Choosing locally sourced, recycled, or renewable materials helps reduce the carbon footprint associated with transportation and extraction. The relationship between energy consumption, water consumption, and consumers is a complex and multifaceted. Consumer behavior plays a significant role in determining the overall level of energy consumption and water consumption. For example, consumer choices about the types of products and services they use, such as appliances, can significantly impact their energy consumption. Consumer decisions about using energy, such as turning off lights when not in use, can also impact energy consumption. Consumer preference for energy-efficient products and services can affect overall energy consumption. That's all from me. Thank you.